Welcome back. So in this video we'll be doing question number 13 and 14. So this is the first question that we have. Okay, we're given a square OABC. I hope you can see this OABC, and which is inscribed, which is inside. Okay, in the sense it's inside a quadrant. Now if OA is equal to 20 centimeter, this OA is equal to 20 centimeter. Okay, and they have given this. Now what are the sides? When you look into this graph or into this figure, what are the sides here? OA is equal to AB, this is equal to BC and equal to OC. These are what? They are called the sides of a square. Yes? And what's the specialty about the sides of a square? They are all equal. Yes? All the sides are equal. So if OA is one side of the square, then the other side, without any hesitation, you can say that they are also going to be 20 centimeter each. Clear? Alright, how to find, we're asked to find the area of the shaded region. So how to find the area of the shaded region? It is by finding out first the area of a quadrant, clear, and then subtracting the area of the square. So when you do that, you'll be left only with this section, clear. But in order to find out the area of a sector, what do you need? You need to know the radius. So how do you do how do you find a radius? It is by drawing a diagonal OB. Alright, so I'll just write here OB equal to OP equal to OQ. These are all going to be radius, okay, radius of a quadrant. Clear? These are all going to be radius. Another important property of a square is that all the corners are actually 90 degree, in the sense angle A, angle B, angle C, these are all 90 degree. Clear? Alright. Now, this is also 20 centimeter, this is also 20 centimeter. Now, if you see the diagonal, do you see a right angle triangle? Yes? So, let us consider, okay, the right angle triangle. Why is it called the right angle triangle? It is called so because one of the angles is 90 degree. And how do we know that this is 90 degree? I've already mentioned that each corners of a square is 90 degree. Okay? Right angle triangle, we are going to consider right angle triangle OAB. Okay, so graphically I'll just draw here. Okay, this is not here, so I'll just draw a graph here, the OAB. Clear? This is O, this is A, this is B, this is 90. Clear? Alright, see now angle B will no longer, or angle A will no longer remain 90 because I have what? I have cut. Okay, I've drawn a diagonal here. Clear? So we've removed it. Alright, so this is 90 degree, okay, but not this. Clear? You must be able to draw a box in that. Okay, see something like this, a proper square. So here you cannot. Okay, so we have a right angle triangle. We need to find OB. Okay, why do we need to find OB? Because if we find OB, we get to know the radius of the quadrant, and easily we can find the area of the shaded region. So let us go using Pythagoras Theorem. Okay, so because this is a right angle triangle, we have the full liberty to use the Pythagoras Theorem. Clear? Okay, so by using Pythagoras Theorem, we'll be getting this as OB square, which is going to be equal to OA plus AB. OA square plus AB square. Okay. Okay. Alright, we do not know what OB is, but we do know what OA is. This is 20 centimeter square plus 20 centimeter square. Okay, OB square is equal to how do you go about this? 20 centimeter square plus 20 centimeter square is going to be 400 centimeter square plus 400 centimeter square. Now OB, 400 plus 400 can be written as 800 centimeter square, or else you can write this as 2 into 400 centimeter square as well, right? There's no harm, right? If it's 4, you have the liberty to write it as 2 into 2. If it's 6, you also have the liberty to write it 2 into 3. There's nothing wrong about it, right? So I'll be writing 800 as 2 into 800, 400, because later we'll be making use of that. So we get this as 2 into 400 centimeter square. Now 400 can further be written as 20 into 20 centimeter square. Okay, sorry, this is 2, okay? This is 2. Now, you can write 20 into 20 as 20 square centimeter square. So you can just cut this square root. Clear? So you're left with 20. Root 2 will still remain because it does not have a power 2, so you cannot cut the square root from 2, so you'll be getting this. Okay, so your OB is equal to 20 root 2 centimeter. And what is OB? OB is nothing but the radius of the quadrant. Now we have everything that we need. We know theta. Okay, theta is going to be equal to 90 degree. Clear? Okay, you don't believe me, you just like see, let's go for this. Clear? So this angle O is also 90 degree, so that becomes theta. Okay, so we just have to find the area of the region. So like I stated, in order to find out the area of the region, we just have to find out the area of the quadrant first and then subtract it with the area of the square. Clear? Therefore, area of the shaded region, okay, of the shaded region, that is going to be equal to area of quadrant, okay, or sector, okay, or sector minus area of a square. Clear? So area of a quadrant or area of a sector formula is theta by 360 into pi r square. Please remember this formula. Area of a square is actually side square. So theta is 90 degree, this is 60. Pi, they have mentioned, or they have written there in the side note, that we have to take it as 3.14. Radius is 20 root 2 centimeter into 20 root 2 centimeter minus side square, 20 centimeter square. Okay, so you can just cancel out 9 into 4, 2 into 10, okay, and 2 into 10. Clear? So what do you have? You have, instead of 3.14, can I write it as 314 by 100 into 10 into 10. Root 2 into root 2 is nothing but 2 centimeters square minus 20 centimeters square actually means 20 into 20. It means 20 centimeter into 20 centimeter. All right, so I can write this as 400 centimeter square, because 20 into 20 centimeter you'll get up 400. So you can cancel out this. Okay, so 314 into this will be 628 centimeters square minus 400, and that is going to be equal to 228 centimeters square. Therefore, the area of the shaded region is equal to 228 centimeters square. Quickly moving on to this question. Okay, it's a very simple question. Okay, so this is given AB and CD. Okay, you first read the question. AB and CD are two concentric circles of radius of radii 28. So look at this, it's clearly mentioned, right? You see, we have one radius which is 0 to B, O, that is AB. Okay, AB and CD. Okay, see, okay, let me just clarify. Yeah, okay, see, AB is and CD are there two concentric circles. So when you look at this circle is slightly bigger than this. That means how many circles are actually there? It's an indication that there is a bigger circle and then there's going to be another smaller circle. Clear? Because you look at this, AB is the bigger circle in the sense. Okay, you can start drawing a circle here, it will just encompass like that, and you can draw another circle here which is going to be slightly smaller than AB, right? So there are two circles in the sense. Okay, and they have given that the circle, obviously a bigger circle will have a bigger radius. It's always understood. Yes, a bigger circle will have a bigger radius and a smaller circle will have a smaller radius. So the thing is, we are asked to find the area of the shaded region. So very simple. Okay, so if I take the area of this sector, okay, this is a sector, right? If I take the area of this sector and subtract it with area of the smaller sector, then I end up getting the remaining area. Okay, so let us go. First solution, theta for both the case is given as 30 degree. I can call it the bigger radii. Okay, radii, or just say the bigger radius to be 21 centimeter and the smaller radius, that is 7 centimeter. Clear? And this is for O. Let's just say for O A and B. Okay, see, for O, A and B, okay, that is the bigger radius, and for O, C and D, this is the smaller radii. Okay, therefore very simple, area of the shaded region, okay, shaded region is going to be equal to area of, you can call it the bigger sector, okay, of the bigger sector, or you can say instead of bigger sector, let's try to be more specific here, area of sector, what sector? OAB minus area of OCD. Okay, therefore the area of sector is going to be theta into theta by 360 into pi. Since we're talking about the bigger sector, it's going to be r square. Okay, minus theta by 360 into pi r square. All right, so the next step is replace theta by 30, 360 into 22 by 7, radius is given as 21 centimeter, into 21 centimeter minus 30 by 360 into 22 by 7, the smaller radius is given as 7 centimeter into 7 centimeter. So you just cancel out, okay, 0, and this would be 3 ones 3, 3 times 2 is 6, 7 times 7, 2 times 6 is going to be 12, and 2 times 11 is going to be 22. I start cancelling here. 3 times 1, 3 times 2, 7 times 3, 3 times 4, 2 times 2, and 2 times 11. So you're left with 11 into 21 centimeters square by 2 minus 77 centimeters square by 2. Okay, so 11 into 21, I suppose that must be 231. Okay, 231 centimeters square by 2 minus 77 centimeters square by 6. Sorry, not 2. Okay, it's by 6. So you just take the denominator. So this becomes 231 into, this is 2, so you need to multiply 3. Okay, just this. So something that you have already learned, so I'll not go much into details with it. So 231 into 3 is going to be 693 centimeters square minus 77 centimeters square by 6. Okay, just for clarification, 693 minus 77, 13 and 8, so 616. Okay, so this is equal to 616 centimeters square by 6, and this will be 2 times 308 by 3. So the answer is going to be 308 by 3 centimeters square. Therefore, the area of the shaded region is equal to 308 by 3 centimeters square.